This is a continuation of the Chapter 4 review tutorial series with Problem 19. Problem 19 is a dilation of a triangle. This dilation is with respect to the origin. Now, dilations with respect to the origin, they're much more straightforward than dilations with respect to some offset point, as we did in number 18. The only thing that's required is that you multiply each coordinate of your pre-image points by your scale factor, and that gives you your dilated image. In this case, this image is going to be an enlargement because the scale factor is greater than 1. In problem 18, it was a reduction because the scale factor was between 0 and 1. So let's go ahead and get started, and let's take a look at what we have here. So here is our triangle, x, y, and z. The points are -3, 2, 2, 3, and 1, -1. So our dilated image, let's call this one x prime, is going to be -3 times -3. -3 times -3 is 9. And -2 times -3 is -6. Y prime is going to be 2 times -3, which is -6. 3 times -3, which is -9. And z prime. 1 times -3 is -3. -1 times -3 is 3. Now let's go ahead and plot those points. So we will plot them in blue, and we have 9, -6. So 9, -6 is here. -6, -9. And -3, -3, 3. So -3, 3. And we'll graph the lines. And so what we have is 9, -6 is x prime, and -6, -9 is y prime, and -3, 3 is z prime. Now you'll notice that if we draw lines through the points from x through the center of dilation through x prime, from y through the center of dilation through y prime, and z to z prime, they all move along the same lines, but in opposite directions. Notice that if we had had this scale factor a positive number, they would have moved away from the center of dilation. But because it's a negative number, the original image points move towards and through the center of dilation. So that's always what's going to happen with a dilation with a negative scale factor. The figure moves and swaps places like it was going through a mirror. And so you can see that the blue triangle is in the opposite orientation as the white triangle as it dilates. So that's just a peculiarity of multiplying by a scale factor of a negative number. And now we move on to problem 20. Problem 20 states, you are using a magnifying glass that shows the image of an object that is 8 times the object's actual size. The image length is 15.2 centimeters. Find the actual length of the object. So in essence, what we're doing is we have this object, let's just call it P, we'll make it a big P. This object is 8 times the object's actual size. So this is our prime value, and this is our image. So we're saying to go from here to here, we multiply by 8. So times 8 to get from here to here. So destination divided by source, 8 divided by 1, 8 times the original object. Which means if this object is 15.2 centimeters long, this object going the opposite way is 15.2 divided by 8. So to get from P prime to P, we divide 15.2 by 8, which gives us, oh, that was bad, 1.9. So your original image is 1.9 centimeters. And now on to problem 21. Problem 21 states, describe a similarity transformation that maps triangle ABC to triangle RST. So here we have triangle ABC and triangle RST. Now, it looks as though these two triangles are the same shape. It also appears that they've been reflected. So that's the assumption we're going to go on. Now, what I did was I took BC, because BC in the statement corresponds to ST. I found the length of BC and the length of ST, and using the distance formula, and found that the lengths of these two sides, this one is exactly 3 times the length of that one. So we know that there's a dilation of 3 involved here. So the first thing that I'm going to do is, just for the sake of experimentation, I'm going to reflect ABC about the y-axis. So here we have the blue image of ABC reflected about the y-axis, and then I just dilated it by 3. And when we dilate it by 3, we get this image underneath here, which is directly overlapping on top of our ST. So to describe the similarity transformation, it is a reflection of ABC about the y-axis, and then a dilation of A prime, B prime, C prime about the origin. And now on to 22. For problem 22, we have something similar going on here. It looks like we have a dilation in effect. So I checked ST versus CB, because ST and CB coincide with these two figures. And in fact, ST is 1/2 CB. So there is a dilation of 1/2, a reduction at work here. And it also looks like there's some sort of a reflection. So the first thing I did is to just do the dilation of 1/2 about the origin. So if we take a look at what that looks like, here is the dilation of ABC by a scale factor of 1/2 about the origin. So A is 6, 4. Divide 6 by 2, you get 3. Divide 4 by 2, you get 2. So you have A prime is 3, 2. B prime, we take the -2, 0. -2 divided by 2 is -1. 0 divided by 2 is 0. And then C prime, we take our C of -4, 2. So -4, 2 becomes -2, 1. So there's our A prime, B prime, C prime. And then I noticed that 3, 2 is related to R because R is at 2, 3. We just swapped the two letters. So you can see 3, 2 and 2, 3. What swaps the X and Y? That's a reflection across the line Y equals X. So to test it, I reflected across the line Y equals X, and sure enough, A double prime becomes 2, 3, which matches R. B double prime becomes 0, 1, -1, which matches S, and C double prime matches T. So to reflect about the line Y equals X, what we actually did was the transformation X, Y goes to Y, X. This is a reflection in Y equals X. And so I applied that to this, and we got that. So in closing, to get from ABC to RST, we first dilate ABC by a scale factor of 1/2 about the origin, and then we reflect A prime, B prime, C prime about the line Y equals X. I hope this helped, and we'll see you next time.